So we are now going to deal with solving an OR inequality. So for this one, OR really means this idea of union. So again, like the last time, I'm going to go ahead and graph this up above. So x less than -2. This is going to be an open circle at -2. This is going to be a graph to the left. X greater than 3. There's going to be an open circle at 3 and graph to the right. So I've graphed them both up above, and unlike AND, where we're just looking for the intersection, by the way, there is no intersection between these two graphs. With OR, what we're doing is we're actually just taking those graphs and bringing them both down and putting them on the line. And so my final answer will be from -2, that's a solution, and then from 3, open circle, those are solutions. And so I just want you to get the concept of an OR statement, and what that is, you know, for example, is x equals 10? Is that a solution or not to this statement? Well, let's plug it in and see what happens. 10 is less than -2, or 10 is greater than 3. We're just going to test a value. I just want you to get the concept here. Is that true? Is 10 less than -2? That's not true. That's false. Is 10 bigger than 3? That's true. So half the statement is true, half is false here, but there's an OR statement. Do both statements have to be true? No. So if one statement is true, then then the statement is true for an OR statement, either or. And so that is a solution, and there's many solutions here and many solutions here. They're not shared in common. And so the union just means all the solutions are valid. If it's a solution, bring it down to the line. Just to look at one more problem, here's an AND problem. I want to show you the difference here between an AND and OR. First we're going to do this with AND, and then we'll work it out the other way. So with AND, that means intersection. Up above the line, I'm going to graph x is less than 0. Now I'm going to graph x is greater than -4. That looks something like this. Those are open circles. Similar to the one we did before. Let's just find the overlap here. That's what AND means. The intersection from -4 to 0 is where these two graphs overlap. And if I were to write that in interval notation, that would be -4, 0. Both with parentheses. Now let's change up the problem just slightly. And so I'm going to write a different problem, and this one's going to be x less than 0, same inequalities, x greater than -4. But this time I'm going to put an OR in between. So if you think about these two graphs, so I've got 0, got -4. The two parts look just like that. I can reuse the same values here, but OR means everything comes down to the graph. So it's almost like this comes down to the graph, this comes down to the graph, and it looks like the whole number line is graphed. My only question is, what do I do with these open circles? So if I've got x is less than 0 and x is greater than -4, if I'm going to graph this graph, the whole number line is a solution. The reason for that is because even here at 0, if I were to plug in 0, is 0 a solution? Well, let's see. Is 0 smaller than 0? Absolutely not. Is 0 bigger than -4? Yes. That's an OR statement. If one of them's true, they're both true. So that's a closed circle there. It's covered because this graph 0 is on. And here, same thing here. -4 is on this graph, even though it's not on that graph, it's still a solution. We would notate this solution maybe a little differently. This would be all reals, or we could say from negative infinity to positive infinity. That is the end of the screencast. It is about 5 minutes long. I hope you enjoyed it.